Hey everybody, welcome back to AI Every Day. Not every day, coming back after a hiatus, and I'm going to be back on one as I'm going to take some well-deserved time off coming up. But I did want to check in with everybody and get an episode out, talk a little bit about what's going on in AI. Although I haven't been producing a lot of podcasts over the past 3 or 4 weeks, I have been very interested in a lot of the developments. I think the thing that strikes me from this week is the explosion in nVidia stock after they announced a huge lift in their outlook driven by demand for hardware powering AI. But I also just got back from Dell Technologies World this week, where I was there with Faction talking about our multi-cloud data services. But one of the things that's interesting is tons of the agenda warped around AI. And I think it was something that was a little late breaking. And I've actually seen this happening at other conferences. Someone on my team went to GlueCon this week. There was a whole ton of interest that sort of rounded out the agenda. And that conference leaves some space available for things that are last minute topics of keen interest. And AI really dominated that. I think it's really interesting because it harkens back to this thing that I have been talking about for a while now, which is that it's still early days for AI. And I'm reminded a little bit of the early days of the internet, circa 1994, 1995, I got involved. And at the time, dial-up modems were just starting to penetrate the general consumer business. Netcom, that I worked for briefly, was the first provider to offer unlimited dial-up internet. So you could call in and stay dialed in 24/7 with your modem if you were inclined. And I actually usually did. Who needs a phone? But of course, a lot of our customers too were just getting online for the first time, and it's impossibly slow compared to today, of course. The entire backbone of the internet, I believe in 1994, 1995, carried less traffic than my cell phone does doing a speed test nowadays. The entire internet. And it's been 28 years, so you expect some evolution. But I think that's an interesting corollary. And ponder that even in 1994, 1995, the bounty of information that you could get from the internet was unbelievably large. Now, granted, it didn't take the same form. It was harder to find things on something like a Usenet group versus today having Google and the World Wide Web. But you could go to Usenet groups, for example, and get impossibly dense information at the time, or even ask questions specifically of people. Anything that interested you, anything from scientific topics to social topics to even buying and selling. I actually paid for a lot of my expenses in my last year of school using sales I was conducting on Usenet of collectibles. You think about that and translate it to today, it was already incredibly useful in 94 and 95, so much so that I was convinced it was going to change the world, and it did, of course. But the internet was such a pale shadow compared to what it became in the modern era. And obviously, things like mobile devices and high-speed broadband are some of the revolutionary step functions of that technology growth. Obviously, tons of things from a software perspective that enabled it as well. But it's interesting to think about what is going to happen with AI. On previous episodes, I've highlighted things like Andre Kaparthy and his tweet where just changing the token vocabulary during a model training run to be a power of 64 shaved something like 20 or 25% off the entire training run in terms of time. Those are the kind of silly off by one type errors that you wouldn't see in an extremely mature technology. It's the equivalent of in the early days of the internet, security was a complete afterthought. You had systems that could log into other systems just because of what they said they were. They would say, oh, I'm a system that's part of your home network. Not looking at the network, just an assertion of identity based on a domain name. And this target system's like, okay, come on in. And of course, there were some really big, interesting things that happened, like the Robert Morris worm that spread like wildfire throughout the internet, just using that sort of misplaced trust to insinuate itself into many systems, right? And it was an accident of sorts, even getting out into the wild, and yet it did, which I guess is maybe why virus ended up feeling like a really appropriate name for it. I think we're at that spot in AI. We are seeing so many fundamental advances, certainly on the hardware side. The demand of nVidia is just a reflection of demand for compute hardware to train and run inference on models. Facebook also announced in the past couple weeks that they are going to be producing specific hardware for inference, maybe training as well, but that they're going to have some AI-specific hardware coming out they've designed in-house. The last time I think I gave you a tour of an AI tool, it was Meta's Segment Anything model, which is super cool. There's actually a version of that that's running in video now as well, object segmentation out of video streams. But in the meantime, it's amazing to think about how there'll be all these hardware advances, all these software advances, all these techniques and tool advances. And I think we are nowhere near the end. I mean, infinitely far from this will still be something that's getting evolved decades from now, I'm sure. But I think that we're going to have incredibly low-hanging fruit. There's fascinating papers that have come out in the past month. There's a really interesting paper that sort of applies the same techniques of taking a discrete Fourier transform, which basically converts like a wave form, like a sound wave, into a function and back. And it's a fantastic way to do compression. In fact, like lots of audio compression codecs are built on doing fast Fourier transforms. They have many other uses. But one of the things that's really fascinating to me about fast Fourier transforms that I really didn't actually even know until this AI-related paper came out and I looked into it a little bit was that fast Fourier transforms sometimes get better results on computers than running discrete Fourier transforms, even though discrete is supposed to be lossless and fast Fourier transforms are lossy. And the reason for that is that CPUs and the memory registers of a CPU don't store floating point numbers in a 100% precise fashion. And this is why in a lot of programming languages, you could declare a variable. If you were to declare a floating point number and say something like, this number is 35.0, and then you were to assign it to another variable and print that variable, it might tell you that it was 34.999999997 or something. Then there's a little bit of entropy at the very end of that. So if you apply that to the matrices that form the neurons of a machine learning model, right, all the parameters, the weights and biases that get trained, then it turns out that so it appears in the paper. I'm giving you a sort of inexpert opinion about this, but the paper makes it seem like there's a certain problem with precision because, of course, things are being trained on floating point numbers in GPUs as you do training runs, and you use loss functions to adjust the weights and biases of a model. And in the same way that a fast Fourier transform actually tends to throw away a little bit of the extreme end of precision of some of those calculations, it seemed to turn out that throwing away some of the extreme end of those calculations on the training model did exactly the same sort of thing and actually improved its accuracy. Not because the algorithm for an FFT in theoretical space was more accurate than a discrete Fourier transform, but because on actual physical hardware, where there was a lack of perfect precision all the way to the end of the floating point number, that basically was smaller. The hardware error was larger than the software error, is what we'd say. And so reverting to the software error actually made the whole model more accurate. And of course, in the same way that a fast Fourier transform is actually much faster than a discrete Fourier transform in terms of computation, their version of doing this for training an LLM with self-attention mechanisms and a transformer was also dramatically faster. Totally interesting stuff. In the sense that not necessarily the math and the model techniques are going to appeal to everybody. What's really interesting, though, is that this is totally fundamental stuff. When you have an advancement that goes, hey, look, we can shave half, 3/4 more off of training time and actually improve the accuracy as we do it. That just tells you that we are nowhere near the end of the road. And this is just, of course, one thing that's coming out after another. So you take a step back and you think about the state of the state with things evolving, and then you think, okay, there are billions of dollars going into AI startups right now. There are thousands of people entering the space, learning more. I'm certainly one of them, trying to learn more every day, sharing with some of you. And I really love talking about the things from a technologist and futurist standpoint because I've been through a lot of changes in technology. But I also love learning the nuts and bolts. I've been going through from the very beginning of AI 101, if you will. Like technically it's 221, but going through training AI models through linear regression and then multiple linear regression, polynomial regression, into neural nets and so on. The amazing thing that I continue to be grateful about in the grand scheme of things is that the community around AI and ML is unbelievably generous with its time, energy, and knowledge. Thank you all. This is good for the human race, right? This is not a time for us to be hoarding knowledge. I honestly feel like I know that there's a commercial drive to all these things, and investors need to make dollars and so on. And my third patent just issued, so it seems slightly hypocritical, but I'm really grateful for people not making an effort to just patent everything, and that there's a lot of publications going on. It's the stuff of life and death, maybe more so than in a lot of cases. The advancements that we're going to make with technology like this, with the enhanced productivity and the ability to do things. Large language models, or the technology that sort of powers large language models, can be put to other uses and is being put to other uses. It's not just chatbots and autonomous agents. So our ability to do things like discover new pharmaceuticals, build stronger material science, things like that really depends on some of these advancements. And this is the kind of stuff that ultimately done well should allow us to live longer lives, more productive lives, learn more, do more. I can't wait. And I think about the intersection of technologies like Apple's reality glasses that are going to be coming out in theory at WWDC next month, and things like Rewind.ai, which is this pretty amazing product. If you didn't catch it, it was product of the day, I think, on Product Hunt one day, but it captures everything on a Macintosh if you have an M1 or M2 chip that your Mac ever sees. Like if it's on the screen or it crosses an audio channel, it basically indexes all the text and audio. And I think clips of video, right? It's getting the audio stream from the video. It makes it searchable forever. It uses probably some kind of vector database, some kind of fantastic compression to draw the relevant bits out. And it's mind-blowing to think about a quote-unquote perfect recall. I was jazzed to see nVidia pop. I actually own some nVidia shares, so personally happy to see my tiny chunk of nVidia stock rising, but much more just to see their success in this space. And nVidia, as I mentioned when I recapped the GTC keynote, which I think was the first of the AI Everyday podcasts that I did, is really also a software company. They're doing so much in terms of foundational models, and I've talked about before the set of foundational models that they're releasing. This stuff is changing so fast too. Even stability, hats off, right? They're testing Stability XL, which is a new version of the Stable Diffusion models. There was 1.5, It's going to be a Stable Diffusion XL. Seems to do some amazing image generation. It seems to require, I will say it's fantastically good at getting images right in a more of a less sophisticated prompting fashion. This is something that Midjourney is already really incredible at. And Stable Diffusion is capable of producing amazing looking art, but it's a little less automatic in the way that it gives you interesting, artistic, super usable results. Now, I find Midjourney really painful in some ways. Like, I have tried so hard to render things sometimes. Like, at one point, I was trying to build a compound image, and I was describing a prison where the bars were made of clouds. And I tried over and over. I tried like 100 different prompts. Maybe somebody who's listening will figure this out for me. But I was never able to get it to do it. I just kept getting prison cells in cages that were floating in clouds. And I would try to do things like -no metal, and I would still get terrible, totally incorrect results. Something I really appreciate is that there's a wider variety of tools in the market. Now, there are so many cool things that have happened, by the way. I regret that I haven't been able to do more episodes lately. And like I said, I'll probably try to get another show or two out before I take off on a little bit of a vacation. But things like Drag Your GAN is just amazing. And you can Google for Drag Your GAN if you haven't seen it. I feel like everybody's seen this because it was the coolest thing on earth, basically. At least the week it came out. I wouldn't trade it for anything. Just an amazing thing where you see these I think, diffusion-based models that have generated an image. And I honestly didn't even dig under the hood of the technology or the paper yet. So when I hear Drag Your GAN, I assume generative adversarial network, and I don't know if that means it's using like a second model as like a discriminator with the output of a stable diffusion or something, or how that's working. But you can see it do things like, there's an elephant in one picture and it's taking a step, and they grab its front foot, and they pull it a little forward with a little dot. You see the foot move. But all the intermediate steps in the final image look realistic. So it's like a Photoshop editing of an image that's like 100% context aware and looks real automatically. Which, I mean, leads to Adobe, who launched a bunch of powerful things for Photoshop that are supposedly out. I mean, I actually want to open it up right now and go test it. And I saw both really amazing things as well as totally goofy things. Like I saw someone highlight a face and add a beautiful beard or something like that, and it just looked completely goofy, whatever it did. But the flip side is some of the stuff that it does produce is absolutely amazing looking. So I'm really excited about that. Thanks for joining me. Hope this little brief catch-up that's not so brief, but I hope this catch-up is really interesting for you. And I will hopefully get another show out, and maybe we'll talk a little bit about dragging your GAN maybe next week. Or I might describe some of the more advanced things around language chains. LangChain, which I've talked about on the show, has continued to gain traction. I've actually got hands-on, and I've written some code to use LangChain to digest things in a sophisticated fashion, right? Being able to go after certain types of things like use case documents and do sentiment analysis to them. It's quite interesting. So I'm looking forward to sharing some of that and all the other advances going forward. And I'm not gone. Little hiatus and a little more to come because of my vacation, but I'll be back with a vengeance with you mid-June, and I'm looking forward to sharing more of what I found.